Lesson 3: Discrete Probability Distribution. In this lesson, we will be focusing on the probability distribution of discrete random variables. When we say discrete, these are variables that can be counted. What is discrete probability distribution? A discrete probability distribution, or a probability mass function, consists of values a random variable can assume and the corresponding probabilities of the values. A probability distribution of discrete random variables has two properties. These properties will help us determine if the given distribution represents a probability distribution of discrete random variables. So the first property is the probability of each value of the random variable must be between or equal to 0 and 1. In symbol, we write it as 0 is less than or equal to p of x is less than or equal to 1. The second property states that the sum of the probabilities of all values of the random variable must be equal to 1. In symbol, we write it as sum of p of x is equal to 1. Now let's consider the given probability distribution of the probability mass function of discrete random variable x, which represents the number of blue balls. How do we know if this distribution represents a probability distribution of a discrete random variable? So we simply go back to the two properties of a discrete probability distribution. So first property, we must check if the values of p of x is less than or equal to 0 and 1. As we can see, 1/4, 1/2, and 1/4 are the values of p of x. And if we check it, these values are less than, or they are between 0 and 1. Therefore, it passes the first property. Now let's have the second property. It says that the sum of the values of p of x must be equal to 1. So if we add 1/4 plus 1/2 plus 1/4, it is equal to 1. Therefore, it passes the second property. If it passes the first and second property, then the given table represents the probability distribution of a discrete random variable. Now let's have the second example. Let's check if this table represents discrete probability distribution. Now, first property, we must check the values of p of x, and it must be less than or equal to, or between or equal to 0 and 1. So 2/4, 1/8, and 1/2 are values between 0 and 1. Therefore, it passes the first property. For the second property, we will try and add 2/4 plus 1/8 plus 1/2. So if we add it, it would be equal to 9/8. As we can see, 9/8 is not equal to 1. Therefore, it does not pass the second property. So if a distribution passes the first property but it doesn't pass the second property, then it does not represent a probability distribution of the random variable x. Remember, the probability distribution of a discrete random variable x is a list of each possible value of x together with the probability that x takes that value in one trial of the experiment. Now let's try this other example. This time we are not given a table, but we are going to create a probability distribution when given a word problem or when given a random experiment. So suppose 3 coins are tossed. Let y be the random variable representing the number of tails that occur. Find the probability of each of the values of the random variable y. So in making a probability distribution for discrete random variable, we follow the following steps. Step 1, determine the sample space. Since we will toss 3 coins, let h represent the head for the first outcome and t represent the tail. Step 2, make a table for the random variable y. And step 3, construct a probability distribution for the random variable y. Now, following the 3 steps, step 1 is to identify the sample space. So using the formula for sample space, s is equal to n raised to the power of r, we know that n is the number of outcomes when we toss a coin and there are two outcomes. So n is equal to 2. That's the head and the tail. And for the r, these are the number of objects observed. So r is equal to 3 since we are observing 3 coins. So s is equal to 2 times 2 times 2. It is equal to 8. Now we know that there are 8 possible outcomes in the experiment. For step 2, we make a table for the random variable y. So listing all the possible outcomes, we know that there are 8 possible outcomes. So when we toss 3 coins, the 8 possible outcomes are HHH, HHT, THH, TTH, HTT, HTH, THT, and TTT. Now, the random variable y represents the number of tails. So we count the number of tails in each outcomes. For the first outcome, there are no tails, so we assign the number 0. For the second outcome, there's 1 tail, so we assign the number 1. For the third outcome, there's 1 tail, so we assign the number 1. And for the fourth outcome, and for the fifth, for the sixth, seventh, and eighth, we do the same. So we know that the values or the possible values of the random variable y is 0, 1, 2, and 3 based on column 2. Now for step 3, we construct the probability distribution of the random variable y. Now remember from step 2, we know that the values of the random variable y ranges from 0, 1, 2, and 3. Now for the probability of the random variable y, we count the total number of outcomes and it's 8. And then we count the probability of appearing the values of y in the experiment. So for 0, 0 appeared once in the values of y. So our probability of having 0 out of the 8 outcomes is 1. So the value is 1 out of 8 or 1/8. Now for the value of y, which is 1, we count how many ones are there in table or step 2. In the table in step 2, so there are 3 ones. So there's 3 possible values of y out of 8 total outcomes. For the 2, same, we count how many 2's are there, and there are 3 2's, so our probability is 3 out of 8. For the number 3, there's only 1 3 in the outcomes in step 2, so the probability is 1 out of 8. Now another way of creating or representing a probability distribution is through a histogram. A histogram is a bar graph. To construct a histogram for a probability distribution, we follow these steps. Step 1, we plot the values of the random variable along the horizontal axis. Next, we plot the probabilities along the vertical axis. And in plotting the probabilities along the vertical axis, you can change fractions to decimals, or you can have fractions and not change it to decimals. So, in illustration, this is what a histogram looks like. So in the x-axis or in the vertical axis, we can see the values of the probability of y, and in the horizontal axis, we can see the number of tails for the random variable y. So that is how we create a probability distribution for a random variable. Now here's the words to ponder from this lesson. The probability of achieving the outcome you want increases when you let go of the need to have it. I hope you learned something from this lesson, and do not forget, always have a statistic amazing day.